Okay, let's take a look real quick at, this is not a big deal, this section. Let's get all the phones away. Okay, we're looking at how to, essentially this is about how to graph radical functions. And it's not hard stuff because they all look essentially the same. Now the way we can look at this, remember how we've done this in the past when we've had things like absolute value functions or graphing parabolas in chapter 5. We always started with a parent graph, and then we were able, if we could find, for example, the vertex, we could move the vertex around and flip it around, things like that. That's what we're going to do with these too. The basic graphs of a square root function and a cube root function look like this. A cube root function goes forever to the left and the right, and it climbs up forever and goes down forever. It's not restricted. Okay, so the domain, I could put in any value of x into a cube root function, and I'm going to be on the graph someplace. For example, if I wanted to put in the value x equals 4, well, there's going to be a y value, right about there that goes with that, right? Now on a square root function, that's not the case. A square root function has a definite starting place, and then it's either going to go to the right or the left from there, depending on whether I'm multiplying it by a positive or negative number, okay? Why is that? Well, that makes sense if you think about it, because we've always had a rule for square roots and for all even roots. We can't take the square root or any even root of a negative number, right? And so it wouldn't make sense for us if I wanted to find what the graph of y equals the square root of x looks like when x is, for example, negative 10. That makes no sense because I can't take the square root of negative 10 for real numbers anyway, right? And so it's not graphed over there, okay? All right, so we'd say then that, and we'll get into this in more detail later, but the domain of a cube root function is just all real numbers. I can put any value of x into a cube root function, there's no problem, okay? And that makes sense also because we can take a cube root of negative numbers, right? We just can't take a square root of negative numbers. The range would be all real numbers. Even though this is flattening out, this graph is going to go up forever in the y direction, and it's going to go down forever in the y direction if I go backwards. Okay, so the range would also be all real numbers. Now for the square root function, it's not that way. For the square root function, it looks like our domain is starting right there at that starting place at x equals 0, and it's going forever to the right, but it's not going at all to the left. So for that reason, we'd say that the domain is x is greater than or equal to 0, but that's it. It's restricted. What about the range? Well, the range is starting at 0, and it's going up, right? And so the range would be all values of y that are greater than or equal to 0. The easiest way to determine what the domain and the range of a function are is look at their graph. Just look at the graphs. I can tell from the graph of this thing that the x values are going to the right forever and the y values are going up forever. Right? So that's my domain. That gives me my domain and my range. Okay? Let's see. Okay, what happens when there's a number in front of the radical? So what if we put a 2 in front of the square root of x or a negative 3 in front of the cube root of x? Okay, if I put a 2 in front of the square root of x, all that's doing is it's going to multiply all those values by the y values by 2, right? And so instead of, now let's just backtrack for just a second. If we look at this graph right here, when I put in x equals 1, what's the square root of 1? Well, it's 1. So the y value is just 1, isn't it? Right? That's an easy point to check is x equals 1. If I put in x equals 1, I get back a y value of 1. If I put in an x value of 4, the square root of 4 is 2, and so I'd get back y equals 2, right? But if I multiply that whole thing by 2, whoops, look what's happening. Okay, now when I put in an x value of 1, I'm getting back a y value of 2, okay, because I've multiplied it by 2. What about when I put an x value of 4 in? Instead of getting 2, now I'm getting 4, right? So it's stretching it out vertically by a factor of 2, okay? What's this going to do when I multiply a cube root by negative 3? Well, it's going to do two things. Okay, first of all, it's going to stretch it vertically by a factor of 3. So whereas with my parent function, when I put in a positive 1, I get back a positive 1 because the cube root of 1 is 1. Yes, ma'am?
So even roots are functions, but odd roots are not?
No, odd roots are functions because they pass the vertical line test.
Well, if you go up to them, they look like what they're like.
Oh, the one on the next page?
Yeah.
Okay, we'll look at that in a second. It's just probably the way, it will be a function, I promise you, it will be a function. You're thinking that because it has a steep graph right there that they line up vertically? It's just a really steep mountain, but it never is actually vertical, okay? The difference being they're both functions, but this one does not have any restrictions on the domain. This one does. Only the x values that are graphed are the ones that work for that function, okay? So there is a difference, but they're still both functions. Now look at this one. If I take y equals the cube root of x, when I plug in 1, I get back 1 again. It goes through the point x equals 1, y equals 1. But if I go forward and look at what happens when I multiply by negative 3, it does two things. When I go out to x equals 1, first of all, instead of going up, I'm going down because that's what the negative is doing, right? It's flipping this thing. And the value, instead of being x equals 1, y equals 1, it's x equals 1, y equals negative 3, right? It's stretching it by a factor of 3, and it's flipping it over the x-axis, right? So those are the two things it's doing. Okay, so it goes through the point, instead of going through the point 1, 1, it's going through the point 1, negative 3, okay? Oops, I don't know why that showed up twice. Okay, so generalization, what can we say? If we're dealing with a square root function that's multiplied by some number a, what impact does that have? Then that means that it's going to start at the point 0, 0, and it's going to go through the point 1a instead of the point 1, 1. Okay, so that's how we can sketch this curve or recognize it, is by doing that test. Okay? Let's get those phones away, please. Thank you. Okay, what about this one? What's the generalization for a cube root? If it's being multiplied by some number a, then it's starting, it's got that midpoint, that starting point at 0, 0. And if I go forward, positive 1, instead of going through the point 1, 1, I'm going through the point 1a. And if I go backwards, because notice, if I go back and look at this parent function, this cube root has a lot of symmetry, right? If I take this thing and put a tack in it right at the origin, right at its sort of its center point, and I spin it 180 degrees, it lines up perfectly. So the right edge and the right part of this, right, the right piece of the function and the left piece are totally symmetrical. They're just spun around each other, right? And so when I go forward, I go through the point 1, 1. When I go backwards, I go through the point negative 1, negative 1. Right? If I multiply by a, it's changing both of those. Instead of going through the point 1, 1, now I go through the point 1a, and instead of going through the point negative 1, negative 1, I go through the point negative 1, negative a. That's how it's changing. Okay? So let's graph this thing. What's this one going to look like? What kind of function is it? Square root or cube root? Square root. Okay, so this is going to be the one that has a definite starting place, right? What's a equal to here? Negative 4, okay? So what's that mean? Where is it going to start? If I wanted to graph this guy, right? It's starting where? Well, it's starting at 0, 0, right? So we know it's going to start at that point. But it's going to go through the point 1a. Well, what's a? Negative 4. So I'm just going to go over 1 and down 4, and there's my second point. And I know what the shape is, right? The shape is it starts steep, and then it levels out. So that's what it's going to look like. Does that make sense? Okay. Questions on that? That's it. That's how we sketch those things. We got to find where's the starting place. Well, 0, 0. And you know, what's gonna be the point that it goes through? One what? Okay? Just those 2 points is enough to get a sketch or to recognize the graph. Okay? So that's it. Okay. What about, now what happens, let's do one more of those. Let's do one more of those. Let me give you another one. Let's just practice that real quick. So what if I gave you, for example, I kind of like writing on this black. What if I gave you instead, how about y equals 2 times the cube root of x? Now what's that one going to look like? Square root or cube root? Cube root. So this is the one that's going to go forever in both directions, right? It doesn't have a starting place. It's got that rotational symmetry. Now where is the center going to be? 0, 0. Okay, so we got a center at 0, 0. And it's going to go through the points positive 1, A. What's A? 2. So I'm going to go over 1, up 2. And it's going to go through the point negative 1, negative A, right? So then we're going to go backwards 1 and down 2. So it's just going to look like that, right? And it's always got the same basic shape. Okay, what if that had been instead, what if that had been y equals negative 2 cube root of x? Yeah, okay, then it's going to go through the point 0, 0, but it's going to go through the point positive 1, negative 2, because that's A, right? So 1A would be down there, and negative 1, negative A, the opposite of A would be positive 2, be up there. Yeah, so it would look like a reflection. So it would look like that. Okay? All right, so now the question is, how can we know what the A does. The A predicts the shape of these things, whether they're reflected, whether they start up or start down, and how stretched they are vertically. How can we move them around on the plane? The answer is in the very same way that we did with all the other stuff. We'll establish, instead of really being a vertex this time, it's going to be our starting point for the square roots, and it'll be sort of the midpoint, right? The point of symmetry for the cube roots. That'll play the same role as the vertex did in a quadratic, a parabola, or an absolute value function. But we're going to have the same kind, we're going to have an h and a k, just like we did before. Okay? So if we want to move this thing around then, we could add this x minus h inside the radical, subtract h from x, and that's going to be the x coordinate of that special point, and k is going to be the y coordinate for both functions, a square root and a cube root. So let's just try this then. What do you think is going to happen with, okay, so if we want to sketch these things, now we got 2 steps. We've got sketch the graph, sketch the original graph without worrying about the h and the k, right? Like we just did. And then if it actually does have an h and a k in there, then we'll shift it based on the h and the k. H is telling us how far we're shifting it to the right, because that's the x coordinate of our special point, and k is how far we're shifting it to the left. Now, I don't care if you do it this way. This is the way the textbook, and a lot of textbooks tell you to do this, is to graph it once and then shift it. But I think, honestly, I think you can just as easily say, okay, now, where is h and k? Put the special point, and from that point, we'll use A to sketch the graph. We'll try it both ways, and you can take your pick. Okay? They mean the same thing. So what if we want to do one like this? Let's try this guy. So if we want to sketch y equals the square root of x plus 1 minus 3. Okay? So first of all, let's establish what are all the numbers here. We just got to know what's a and what's h and what's k. So let's write down this is a square root function, right? So we're going to compare it to a times the square root of x minus h plus k. What's our a? 1. Everybody see that? Okay. So a equals 1. What's h?
One.
Not 1, negative 1. Because it's the number that's being subtracted from x. And so just like it's always been with the h's, it's going to be the opposite of that operation between x and the number, isn't it? Every time. So h is negative 1. What's k? Negative 3. Okay, so if we start it, we can do this, that's fine. We could start with the parent graph if we want to. Let's just make that green. Sorry. We can start with the parent graph, y equals 1 times the square root of x, and that's just going to be a graph that goes through the point 0, 0, right? And the point 1, 1. Agreed? Okay, so I can take this and just do a normal graph with it. Now, what's it doing, though, if we're taking this graph based on A is 1, and we shift it by that amount? What's that going to do? So we're going to go where? Left 1 and down 3. Good. Okay, so we'll go left 1, left 1, down 3. Take that whole thing and just shift it down there, right? So then this point is going to move down to there, right? This point is also going to move back 1 and down 3. And so now it just looks like that. That's our shifted graph, right? Make sense? We graph, and this isn't a bad way to do it. This is the way that the textbook, the examples in the textbook are gonna illustrate this. First, you graph the parent function, which is just y equals a times the radical. And then you use the h and the k to slide that based on the h and the k. And just slide both of those 2 points, and then you can resketch it. Okay, that's fine. And if you want to do it that way, that's great. Plug your ears if you don't want to hear a shortcut. You can also do it this way, though. We could say, okay, where's h and k going to be? And just go right to the location of hk, the location of the special point, and then use a. If we know we're starting there, we're starting at the point -1, -3, and we know that a equals 1, that means that when we go 1 to the right, we're going 1 up, and we can just sketch the graph that way. Right? Yeah, so the shortcut is you start with the location of hk, and you use a to sketch the graph.
So you go, x is -1, y is -3.
Mm-hmm. And then you use a from there. Now let's do one like that. Let's do one like that, just so we can get a little practice. Okay, so what if we've got, I'm going to give you a new one. What if we've got, this time, let's say, y equals -2 times the square root of x minus 3 plus 1. Okay, so first, and like always, we want to establish what are the values of a and h and k. So a is -2, good. H is 3. Everybody see it's positive 3 because that's what's being subtracted. Okay, and k is positive 1. Okay, so if we wanted to graph this then, or sketch this, okay, so we're going to go, the location of the vertex, or the special point, it's not really a vertex, is going to be 3, 1, right? So we would just go over 3 and up 1, right? Everybody agree? So that's the special point. And what's a equal to? -2. So what's that telling us? That's telling us that if we go over 1, we're going to go vertically -2, right? So if I go over 1, I'm going to go down 2. And so there's my second point. And I know this thing is going to look like that. Okay. That's what I would call the shortcut. Instead of having to graph it, and you see the difference, instead of having to just graph it twice and shift the whole thing, we're just gonna shift the starting point and graph it once. Okay, let's try another one. Let's try a cube root. How about if we have y equals negative 3 times the cube root of x plus 1 minus 2. Okay, what's a? Negative 3. Okay, and then hk, the point hk is going to be what? What's h?
-1, -2.
Okay, everybody see that? H is -1, right? Because I've got a plus sign there. And then -2, right? So that's going to be the special point on the cube root graph, the one in the middle, right? So then that special point is going to be back 1 and down 2, right? So there. Everybody agree? Okay, now I got to get the other 2 points. If I go to the right 1, I'm going to go vertically A. A is -3. Everybody see that? So I'm going to go this way 1, and I'm going to go down 3. Right?
Yeah.
There's my second point. So I know on the right side, it's doing that. It makes sense that it's opening down instead of up, because A is negative, right? When A is negative, it's starting down. On the other side, I'm going to go back 1, and vertically by -A, which means I'm going up 3. So there. Just doing that. Okay. You could, if you wanted to, it's fine. You could have just done this. We could have just started at 0, 0, and graph just the -3 part, where it's going over 1 and down 3, back 1 and up 3, and then shifted, if I wanted to, taken all 3 of those points and just shifted them by that amount to get the red graph. Same thing. Just 2 drawings instead of 1. Okay? Questions on that? All right. Okay, let's just describe this one. What kind of graph? Square root. What's A?
-2.
So what's that mean about the graph?
Opens down.
Okay, it's gonna open down instead of up, right? Where is the starting point HK,
2, 1.
right? So that's all we need. We go over 2, up 1, and then we're going down 3, so I scoot 1 to the right and down 3 to get my other point, right? Get 2 points that define the sketch. Right? So there's my starting point, 2, 1, and then if I go right 1, I go down 3 to get my second point, and that's enough. It defines it. All you're going to be doing on the test and the assignments is I'm going to, like you would guess, I'm going to give you a whole series of graphs to choose from, and you have to pick the right one. Well, how do you pick it? Whichever one has the right special points. That's how you would pick it. That's all you got to look at. Okay, and we already did one of these. I'll skip through this. Same deal. Right, we can see if we just look at how this one's graphed. Wouldn't you agree that A is +3? The special point is going to be at -2, -1, right? So we'll go back 2, down 1 to get that middle point. And then A is +3, so I go 1 to the right, up 3, 1 to the left, down 3. Okay. Okay, state the domain and the range. And we'll do that based on the graphs. So if that's the graph, now let's look at this real closely. You can do this all from the graph. This is the one that people try to make harder than it is. If you look at the graph, it's not a big deal. This one, we know that A is 2, right? HK is -4, -1, right? And so what's that mean then? If it's a square root function, okay, if it's a square root function, we're starting at the point -4, -1, and we're scooting to the right and up. So based on that, if we're starting at the point -4, -1, and we're moving in the positive x direction and positive y direction from there, what is the domain going to be of this? X is what? What values of x are graphed there? Is it all real numbers? It's not, is it? It's got a definite starting place. -5, for example, is not on the graph. X equals -5. Where does the graph start? -4, and I want all x values that are what? Greater than or less than that? Greater than. So isn't the domain x is greater than or equal to -4? Right? What about the range? We're starting with the y value, what? -1. -2 won't work. -1 is fine. And we want all the y values greater than. So then y is greater than or equal to -1. That's it. Right? Make sense? Okay, now this one is super easy because there is no starting place. And so the answer is all reals, all reals. Any x value, any y value is fine. There is no starting place. Okay? So the cube roots are really simple. It's always the same answer every time. The domain is all real numbers, the range is all real numbers. It's only on the square roots, it's got to be a little careful because there is a definite starting place. Okay? So that's what we got. I don't know what those pictures are supposed to mean, but there you go. Domain for this guy, all real numbers, range, all real numbers. What's the domain and the range of this guy? So we're starting at 2, 1. We want all the x values greater than, right, to the right of. All the x values that are greater than 2 are okay, because we're taking x values to the right of 2. So what's our domain going to be? X is greater than or equal to 2, because all those x values starting there and going that way are going to be okay. They're on the function. But if I tried, for example, 0, the function is not graphed at x equals 0. Okay? What about the range? We're starting at x or y equals 1, and we're going up or down. Yeah, going down, so less than, right? So range y is less than or equal to positive 1. Okay. Okay. And this guy, right away, what's the answer? It's cube root, all reals. It's cube root. Okay, we can skip this. I think that's it. That's interesting. Let me get you working on this stuff. 10 minutes, yeah. Well, I think what I'll do instead, I'll give you all day Monday in the lab. And I think what I'll do now is I want to just take a quick look at a couple more non-graphing questions. So those that want to redo that test can.
Why don't we use that program
On the graphing.
the
Polysmolt? Yeah, use it on the graphing test. Say it again? Yes, absolutely. Yep. You betcha. On any problem where it asks for you to find the zeros, you can use that on. Or solve an equation or something, you can use it. So you can use it on several on the test. It makes that, honestly, it makes that test really easy. Yes. Yep. Yep. You betcha. Thank you.
Thanks, Ben.
Yep. Okay. Okay, real quick, this is probably all we'll get through. Maybe we'll get through two. This was one people had some trouble with. We can make this really easy. Okay, this is one, especially if they're asking you to find the solutions of this. Now, think chapter 6 for a second. Remember what we did when we were solving equations, when we were factoring or solving. The approach that we take is based on the number of terms in the polynomial. If there's 4 terms, we always, what do? If I get a 4-term polynomial, group it into, it's even, so I get 2 groups of 2, right? If there are 2, we have chapter 7 tricks now that make it super easy. If we have a 2-term polynomial, chapter 7 makes that, makes this test a lot easier for you. Because if we had something like, for example, 3x to the 4th minus, I don't know, minus 81 equals 0, what do we do now? Now that we know how to take roots other than square roots. This would be an easy one. Or we go back to our rule. It's been a few days since we talked about this. Remember, we can go back and say now, just like we said before, if I can point to a single x, I can isolate it using chapter 7 tricks. So I could isolate that x. What are the steps I would go through to isolate x here? Add 81, divide by 3, and then 4th root. Chapter 7 shows us that we can actually do a 4th root on that thing and get an answer, right? So this would be, well, okay, then we'd have to, if we didn't know chapter 7, we got to do difference of squares twice. But we don't need to, because now we got chapter 7. Like I say, it makes the chapter 6 test easier for you, which is good. I mean, because you can still go back and do it, so that's kind of nice. So let's just really quickly go through this one. If I want to isolate x, you told me add 81. So I get 3x to the 4th equals 81. Divide by 3. So x to the 4th equals, what is that, 27? Okay, and then x would equal, you told me a 4th root, but what do I have to remember there if it's an even root? Now if I take an even root, right, just like I had with the square root, that's even. Plus or minus. Yeah, I gotta put a plus or minus there because it's even. So I'd get plus or minus the 4th root of 27, which my calculator just gives me, and that's easy. Right? Okay, so those become very, very simple problems.
So how do you get the 4?
How do you get the 4 in the calculator?
Yeah.
Okay, there's 2 ways. You can do this as the easiest way, while the calculator's coming up, I'll show you this, would just be to say on your calculator 27 to the 1/4 power. Okay, because remember that's how we can always take a root. We can always take an nth root by just taking it to the 1/n power. Right? So let's take a quick look at how this looks on the calculator. So then I could just say 27 to the power of 1/4, and it tells me. I get plus or minus that.
Why is the 1/4?
Because we have a property in chapter 7 that says the nth root of a is the same as a to the 1/n. Okay. And that's by far the easiest way to take a root is to take it to the 1 over that index power. The other way you can do it, Taylor, if you want to, and this isn't a big deal, but you can, if you want to do it this way, if you type in whatever you want, what kind of root are you taking, a 4th root? So if I type in 4, and then I go math, and I choose that 5th option, the xth root, so whatever I just typed in becomes the index. Look what it does. Puts the 4 right there, and then I can just put a 27 there. And I'll get the same answer. Okay?
So you go 4,
for math 5. Okay, and once you do it, you'll see what that means. Okay, and then I get plus or minus. Okay, now back to the problem at hand though. So those are really simple. These are a little bit harder, but not horrible. What do I do with this guy? Well, this is 3 terms, so it's quadratic, right? What we got to see about this one is that this is just like a chapter 5 problem. If I've got x to the 4th minus 10x squared plus 9 equals 0, then that just means that a is 1, b is negative 10, and c is 9, right? But instead of having an x squared and an x, I've got an x squared squared and an x squared, right? And so I get 2 options. I can factor this. It does factor. I made these so they would factor too. I can break this apart into, instead of an x and an x, it's an x squared and an x squared, which I have to multiply to get my x to the 4th. And then my magic numbers that multiply to 9 and add to negative 10. No, negative. Multiply to positive 9 and add to negative 10. So negative 1 and negative, not 10, negative 9, right? Negative 1 times negative 9 equals positive 9. Negative 1 plus negative 9 equals negative 10. Right? And then the last part would just be, now I can solve these equations. I've got it factored into these little equations, and then if I just set them equal to 0, x squared equals 1, or x squared equals 9, right? If I set those equal to 0, everybody with me?
Yeah.
And then my answers would just be what? If x squared is 1, if I square root both sides, not, careful.
25.
It's not just 1. I'm
Plus
plus or minus 1, right? Plus or minus 1, or x equals plus or minus 3. So I get 4 answers, plus 1, minus 1, plus 3, minus 3. And so the biggest would be positive 3. The least would actually be negative 3.
So you just don't even use the one?
The ones, in this case, those are solutions, but I'm only asking for the biggest and the smallest, so they wouldn't even be in there.
Like on calculator, like on the bracket calculator, would you just use like the?
I would just use polysmol too. You could.
Oh, so when it gives you 3, negative 3, 1, negative 1, and then.
Yeah, it'll give you those. If I use that polynomial solver equation, I would put in a4 equals 1, a3 is 0, a2 is negative 10, a1 is 0,
Okay.
a0 is 9, right, when I put in the coefficients, and it'll tell me the answers. But on the non-graphing test, you can't do that. Non-graphing test, you got to do this. Or I could use the quadratic formula, right, because I know a, b, and c. And so if I choose to use the quadratic formula, that's going to work too. I'm just going to get x squared equals negative b, so 10 plus or minus the square root of 10 squared minus 4 times 1 times 9 all over 2. I'm going to get, if I do that, I'm going to get these same answers from the quadratic formula. Okay? Make sense? Okay, either way, I don't care. Whichever way you prefer. It's easier to factor this, but you can always fall back and do the quadratic formula. How can I check my answers, by the way? Yeah, just plug them in and see if they work. Okay.